Hello everybody once again and welcome to Pankaj Assuran Tutorials, and this is one more video on limiting reactant. So perhaps this must be the last numerical on limiting reactant that I'll be discussing with you people. So this is let us get started, and this is a question which says that there's some sorry, there's a reactant called C2H6 which reacts with oxygen to produce carbon dioxide and water, and the balance equation is given here. 2 times C2H6 plus 7O2 will give you 4CO2 plus 6H2O. This is the balanced equation for this particular reaction. Okay, so we are talking about ethane, which is going to be burned in the presence of oxygen, and it being a complete combustion reaction, there must be excess of oxygen perhaps. That's the reason we are getting carbon dioxide and water. So that is the reaction that we are dealing with, and the chemical equation I've just discussed with you, and I've written here the balanced chemical equation as well. Now the questions that follows are A and B. Sub question A says that if 5 moles of ethane is placed in a container with 16 moles of oxygen gas, how many moles of carbon dioxide is produced? That is the A part of the question. B part of the question is, if 30 grams of ethane is mixed with 84 grams of oxygen gas, how many grams of H2O is produced? Okay, so these are the two questions, A and B, the sub questions A and B. Just pay attention to one thing. In the A part of the question, they are asking you everything in terms of moles. Okay, so reactants are given in terms of moles, and the product, that is the CO2 which will be produced, that also they have asked you in moles, right? So you can see here very clearly that in this A part of the question, everything, the reactant and the product, are to be dealt with in moles. In B part of the question, you can see that the ethane has been taken 30 grams, and it is mixed with 84 grams of oxygen, right? And now they have asked you the product H2O. This time it is not CO2, but it is H2O. And here again, they have asked you the grams of H2O that is produced. Okay. So B part of the question is dealing totally with grams. That is the difference between these two questions. Otherwise, everything, the approach and everything is going to remain the same. So let us get started and start with the A part of the question. So first of all, the balance equation we have to see, and it is given here. So it is 2 times C2H6 plus 7O2 will give you 4CO2 plus 6H2O. And the stoichiometric coefficients will be, for ethane it will be 2, for oxygen 7, for carbon dioxide 4, and for water 6. So 2, 7, 4, 6 are the stoichiometric coefficients, right? And the question A is telling you that 5 moles of ethane and 16 moles of oxygen are combined, right? So we will have to first decide which is the limiting reactant. Okay, now either of the reactant can be limiting, but we don't know which is the limiting reactant. And why we have to decide which is the limiting reactant? Because the carbon dioxide that we want to find out, how much carbon dioxide will be formed, okay, that will be depending on the limiting reactant. So which is the limiting reactant? That is very important. So next question comes to your mind is, which is the limiting reactant? LR. Okay, so to decide which is a limiting reactant, I have devoted so many previous videos on that. So by now you should be very clear. Like let us try to find out the K factor for this thing. Okay, oxygen, right? So K factor for oxygen will be for ethane first we'll do. So for ethane, we know there is 5 moles of ethane provided to us. So 5 divided by the coefficient, the stoichiometric coefficient of ethane in the equation is 2. So 5 divided by 2 is equal to 2.5. This is your K value, right? For ethane. Similarly, let us try to find out the K value for oxygen. So it will be 16 divided by 7, which works out to 2.29, right? Now, out of this 2.5 and 2.29, obviously 2.29 is a lesser value. So, the reactant corresponding to this lesser value has to be limiting reactant. So, your oxygen is the limiting reactant. Got it? In the start of this session, I told you perhaps oxygen must, because it's a complete combustion, okay, carbon dioxide and water is being formed. So perhaps I told you oxygen must be a excess reactant, okay, but you can see that it has worked out to be a limiting reactant instant, okay. So it's very necessary that you should not go by chances or any assumptions. You have to literally calculate the constant, the limiting reactant constant K, and then decide which is the limiting reactant. In this case, oxygen is the limiting reactant. Now, since oxygen is the limiting reactant, we will start with directly this method. Now, this method also in my previous videos I have discussed, okay, where directly you can come to the answer, right? So now that we know that oxygen is the limiting reactant, so we are interested in now oxygen to carbon dioxide, okay. So carbon dioxide, the how much carbon dioxide will be produced will totally depend upon the oxygen, right? Because that oxygen is the limiting reactant now. These are the uh, stoichiometric coefficients 7 and 4, right? Okay. So this method, okay, in this method, normally, teachers, they prefer this method directly. So in this method, you have to start. Now, I have already written here how it works, but to explain you, I'm going to write it again. So in this method, you have to start with whatever is already given in the data. Okay, so in the question. So in the question about oxygen, they have told you that 16 moles of oxygen is given to you. Now this is a mole to mole problem. Okay, you are given moles of oxygen and they have asked you to find out the moles of carbon dioxide. Okay, so this is a mole to mole question. In mole to mole question, there will be only one factor. Okay, which you have to use. Okay, and this factor will be in the form of a ratio, which is also known as the mole ratio, right? Now, this mole ratio, you will have to get it from here, from the coefficients, the 7 and 4, between O2 and CO2. So, the mole ratio can be either 7 upon 4 or it can be 4 upon 7. But you have to take the mole ratio in such a way that in the denominator, you should get moles of oxygen. So that moles of oxygen in the numerator over here and this in the denominator should cut out. So I will be preferring 7, 4 upon 7. So 4 moles of CO2 and 7 moles of oxygen. Okay. Purposely I took 7 in the denominator in this factor. Now what happens? You have to use only one factor for mole to mole. So this mole of oxygen and this mole of oxygen will cancel out. Now we are left with these numbers 16 times 4 upon a 7. This will give you a numerical value and you can write this mole of carbon dioxide. So if you work out this 16 times 4 will be 64 times 7, which is equal to 9.14. So you get the answer as 9.14 moles of carbon dioxide. So in one go, this is how you get it. Okay, 16 moles of oxygen times 4 moles of carbon dioxide upon 7 moles of oxygen. Cancel this moles of oxygen, moles of oxygen. This will work out to 64 upon 7 moles of carbon dioxide, which is nothing but 9.14 moles of carbon dioxide. Okay. So we got the answer to the A part of the question. What was the A part of the question? How many moles of carbon dioxide is produced? Okay, when 5 moles of ethane reacts with 16 moles of oxygen. So this is how you should get in a single line answer. This is what you should get. Okay, and put it in the rectangle. Fine. Okay, but we had to decide which is the limiting reactant initially. Fine. Okay, now okay, now here the B part of the question is, can you see B part of the question? Okay, 30 grams of ethane is mixed with 84 grams of oxygen. Okay, and how many grams of water is produced? Now this particular thing, 5 moles of ethane. Okay, this I have given you extra, means if you want to find out how much reactant will be, or if you want to prove that limiting reactant is oxygen, you can go for this step as well, but you can ignore these two steps and let us come to the B part of the question. Okay, now B part of the question, same reaction. So 2 molecules of C2H6 reacts with 7 molecules of oxygen, giving you 4 molecules of carbon dioxide and 6 molecules of H2O. Fine. Now again the reactants are ethane and oxygen. Okay, and the stoichiometric coefficients still remain the same. It is 2, 7, 4 and 6. Fine. But now you can see that in B part of the question, okay, they have given you the reactants in grams. Okay, so when the reactants are given to you in grams, and when you want to decide what is the limiting reactant, then you have to go a little extra step you have to do. Okay, and that is, first you convert the grams into moles. So first I'm going to convert this 30 grams of ethane into moles. Okay, so I'm going to use this formula, N is equal to mass in grams upon the MR of the ethane, and that happens to be mass in gram is 30, which is given to me for ethane. And ethane ka, if you see this MR, okay, that is a RMM value, it works out to 30.06, right? So 30 upon 30.06 works out to around, I think 30 upon, let me work out that, 1 second. So 30 divided by 30.06 is equal to 0.998. Okay, 0.998, right? So this is the moles that you get. And now if you want to find out K, okay, so K will be 0.998, that is number of moles, times the stoichiometric ratio, stoichiometric coefficient of ethane, which is 2. So you will get K as, K you are getting as 0.499, okay, 0.499, which can be nicely taken as 0.5 if you want. Okay, not an issue. Fine. Similarly, I am going to find out the K factor for the oxygen. Okay, so oxygen is given to me as 84 grams, right? So K factor, to find out K factor, first I'll find out the moles of oxygen, which will be N equal to mass in grams upon MR, which is equal to, I think, 84 upon oxygen will be 32. So 84 upon a 32 works out to 2.625. 2.625. Okay, this is the number of moles, and K factor will be 2.625 divided by the stoichiometric coefficient of oxygen, which is 7 in this case. So 2.625 divided by a 7 gives me 0.375. 0.375. Now if you see the K values, okay, 0.375 is a lesser value than 0.5, right? So it leads me to conclude that the limiting reactant is oxygen. Okay, the limiting reactant is oxygen, right? Okay. So what is the amount of water formed? If you want to find out that, then I start from now. I'm going to use this particular method. Okay, that is the teachers they use direct one line may you will get the answer. So what is given to you in the question? Now you are dealing with oxygen and water, right? Oxygen is 7 and water I think it was how much, 6, right? So the stoichiometric coefficients are 7 and 6. Okay, but now this is gram to gram. Okay, this is gram to gram question. They have given you the mass of oxygen in grams, and they have asked you to find out the mass of the water that will be produced, okay, in grams. So this is a gram to gram question. In gram to gram question, there will be three factors. Okay, so I'll tell you how to deal with this. First, start with whatever information about this oxygen is given to you. So the information is 84 grams of oxygen is given to you, right? Now this you will have to multiply by three factors one by one. Okay. Now what are these three factors? I'll explain you. Okay, in steps. In the first, you know what is happening. Now this is 84 grams of oxygen. Now this gram of oxygen has to be cancelled out. So here I'm going to write gram of oxygen. Okay. But then this gram of oxygen, I have to convert it into moles, isn't it? So 32 grams of oxygen is nothing but 1 mole of oxygen. Okay. So the first factor will be 1 mole of oxygen upon 32 grams of oxygen. Is that clear? Okay. This is nothing but the that formula N is equal to mass in grams, okay, upon the AR, right? So you can say that 32 grams, that is AR in terms of grams, that is also known as gram molecular mass. Okay, so that itself is 1 mole. So 32 gram of oxygen is same as 1 mole. So in the first bracket, I'm going to write 1 mole of oxygen upon 32 grams of oxygen. Is that clear? Right. Now I have purposely done that so that this gram of oxygen and gram of oxygen is going to cut. But remember here in this step, your gram is being converted to moles. From year to year, gram is being converted to mole. Right. Now in the next bracket, we are going to talk about water. Okay. See, oxygen gram has been converted into mole. Right. Now we are going to talk about second part, that is the water. Okay, now we have to find out what is the gram of water that is produced. So first we'll find out what is the moles of water. Okay, so to get the mole of water, we are going to take the stoichiometric ratio. Okay, because these 7 and 6 represents the moles. Okay, now this mole of oxygen, okay, uh, will have to come down. So mole of oxygen, because we want to cut it, okay, from the numerator, and here mole of oxygen. So mole of oxygen is 7. See, ratio I'm talking about. Either you'll have to take 6 upon 7 or 7 upon 6. So I'll go by this, sorry, this is 6 upon 7 or 7 upon 6, right? 6 upon 7 or 7 upon 6. So I will go by this ratio, 6 upon 7. Why? Because this 7 is nothing but the moles of oxygen. And this mole of oxygen and this mole of oxygen I can cut out. Okay. So I'll go by this ratio, mole ratio. So here on the top, I'm going to write 6 mole of water. Right. So the ratio is 6 mole of water upon 7 mole of oxygen. That I have taken in this second bracket. Right. Now you can see that mole of oxygen will cut out. Okay. And this was already cut out. So whatever numbers will multiply and divide, that will give you the mole of water. So you will get now the mole of water. Okay. And the answer that you want is grams of water. So mole of water has to be converted into grams of water. Now when you want to convert mole to gram, okay, then you have to use that relationship, that what is the molar mass in gram, okay, that you'll have to find out for water. So mole of water is there over here in the numerator. So here also I will have mole of water, okay, and mole of water will be 1. And for 1 mole of water, how much gram of water should be there? So it will be 18 gram of water, right? Fine. Now you can see very nicely, I will be cutting out with a different ink. Can you see this gram of oxygen? Gram of oxygen is gone. This mole of oxygen and this mole of oxygen is gone. This mole of water and this mole of water is gone. Now we are left with 84 times 1 times 6 times 18 whole upon, you have 34, 32 times 7. That's it, and 1. And what is left out is this grams of water. Grams of water. Now you just work out this 84 times 1 times 6 times 18, okay, whatever it is given. And if you work out this, let me work out quickly. It will be 84 times 6 times 18 equals 9072 divided by is 32 times 7, right? 32 times 7, which is 224. 224. And this works out to 9072 divided by 224 is equal to 40.5. Okay. So this figure 40.5 is nothing but grams of water. And you got the answer. B part of the question. They had asked you how many grams of water is produced. Okay. So this is how we have to work out. Right. So on the left hand side with this white ink, I have written so many things. But while explaining, I thought that I will rewrite the things. Okay. And because to explain, I have to write it again. And I think this was okay. Like this, everybody must have understood this method. Okay. So ultimately, the answer was water produced from oxygen is 40.5 grams. Okay, here also I got 40.5 grams. This is how you have to deal with the questions relating to uh, limiting reactants. Okay, and I suggest students to go for this particular method. Okay, this one. Okay, now there's a name for this method. In my first video, I must have mentioned about the name of this method. But this is the method which most of the teachers, they want the students to do. But let me tell you, you have to understand everything right from the scrap if you want to use this method. Okay, it's not that easy to decide which factor will be having what as a fraction. Okay, particularly when it is gram to gram, there will be three factors you will have to multiply, three brackets. In each of these three brackets, what you will be taking as a fraction, what you will be taking in the numerator and in the denominator, all these things, you'll have to go more in detail. You have to practice a lot of questions, then only it will go into your head and you can start doing it in one go. Okay, but this requires a lot of practice. Okay, so anyways, I have made videos on that. Okay, so you can go through those videos and definitely you will learn how to do it. Okay, so that was all about this limiting reactant. I think I made some 3 or 4 videos on this. Okay, and I found that it was a very very crucial part of stoichiometric numericals. Okay, without this particular thing, stoichiometric calculations were always impossible, right? So I made an attempt to devote some 3 to 4 videos on this limiting reactant itself. Okay, so this was perhaps the last one, And this video also I want to end here. And that's all for today. And if you happen to uh, like my video, then please subscribe to my channel. Bye. Take care, all of you.